All right, Algebra 1, this is lesson 1.7, absolute value equations and inequalities. Your objective, write this in your notes and in your objective calendar. Students will be able to write and solve absolute value equations and inequalities. Let's get started.
So what is absolute value? Absolute value is really the distance from zero a number is on the number line. So what does that look like? So let's say the absolute value of x equals 4. That means x is some number that's 4 away from 0. So if I start at 0, I go 1, 2, 3, 4, and then that's one solution. What's another number that's exactly 4 steps away from 0? Well, 1, 2, 3, 4. That's 4 steps. Even though I'm going in the negative direction, that means that if the absolute value of x equals 4, I mean x can equal 4 or x can equal negative 4. So a quick way to remember this is whatever is inside here must always, when it comes out, must always be a positive number. So like the absolute value of negative 3 is 3. The absolute value of 5 is 5 because negative 3 here is 3 spots, 1, 2, 3, away from 0. 5 is 1, 2, 3, 4, 5 jumps away from 0. So absolute value is just measuring distance from 0. And it turns whatever is in here into a positive value because distance is positive in this case. Okay, let's solve our first one real quick. The goal is to isolate this part and get it by itself. So in order to do that, I'm going to add 2 to both sides. I get 8 equals the absolute value of x. Now we split this up. X can either equal 8 or x can equal negative 8 because both of these positions on the number line are 8 away from 0. A little more involved. Same thing, we want to isolate this part. So in order to do that, we divide both sides by 2. So before we would distribute, we're not doing that now. We're just trying to get this alone. So 2 divided by 2 is 1. So I have one of the absolute values of x plus 5 equals 2. Now I split it into 2 parts. I have x plus 5 equals negative 2. X plus 5 equals positive 2. And I solve. Subtract 5 from both sides. That's an equal sign. I get x equals negative 7 and x equals negative 3. So I have 2 solutions. I have negative 3 and negative 7. So now we have an absolute value inequality. So we want to isolate this, which we already have. Okay, so I'm going to undo that. Yep. And we split it in half. So I have 3x minus 6 is greater than or equal to 9. Okay, and then I have negative 9 is greater than or equal to 3x minus 6, or this part is smaller than negative 9. It could be read either way. So first I'm going to solve this one here. I'm going to add 6 to both sides, and I get negative 3 greater than or equal to 3x. Then I divide both sides by 3 because I need to get the x by itself now. I have negative 1 is it's greater than or equal to x, or x is less than or equal to negative 1. So this is one boundary here. And let's do the one on the right over here. Add 6 to both sides. I get 3x is greater than or equal to 15. Divide both sides by 3. I get x is greater than or equal to 5. So here's the other solution. And we write it like an inequality. So I'll use a highlighter to make it easier to see. This goes that way, and that goes this way because x is less than. It's all these values less than negative 1, and it is also all these values, or also all these values over here. Here we have the same thing. We want to get this alone, which we already have, and now we split it up. So on the right, I'm just going to rewrite it and keep the 20 positive. So this sign here, the inequality, does not change. Over on the other side, my 20 is going to become negative. So now the sign changes directions, okay? So let's solve this one first. Add 12 to both sides. I get 4x is greater than or equal to negative 8. I divide 4 on both sides. divide both sides by 4, and I get x is greater than or equal to -2. So here, do the same thing. I solve to get x by itself. I isolate the variable. In order to do that, I remove the -12 from both sides, and I get 4x is less than or equal to 32. Divide both sides by 4, and I get x is less than or equal to 8. So I have 8 and -2. X is greater than, let's use red this time, -2, so it's going to go that way. X is less than 8, so it's going to go that way. So it can go all the way down until it hits -2, and then all the way up until it hits -8. So this is an AND problem. Okay, the last one was OR. I wrote AND by accident. The last one was OR. This one is AND. Okay, so recap. If I have the absolute value of x is less than 3, that's going to mean x is less than 3, and x is greater than -3, because when I write the negative, I switch the sign. So this is an AND. So I'm going to do it in black. I'm going to have -3 and 3, solid dots, and we're there. If the absolute value of x is greater than some number, that's x is greater than 3, or x is less than -3. Notice we have to switch the sign when we switch this to the negative part. So I'm going to have, excuse me. Hold on. -3 and +3. X is less than -3, or x is greater than 3. That's an OR problem. So your homework is going to be on page 48 to 49. You are going to do numbers 12, 15 through 24, 27 through 38, and 44. That's all I have. Hope this was helpful. You know how to get a hold of me. Take care.